Hello everyone, thanks for giving me this opportunity. I would like to introduce myself. My name is Rohit Sharma, an UG student. We group of three, me as presenting author, my colleague Vinit Jaiswal and Mr. Manish Sharma. I am very pleased to present the presentation on the topic experimental characterization of concrete properties with partial replacement of scrap ceramic tiles. The main outline of my presentation includes introduction, objective, material use, result and discussions, conclusion and reference. The introduction of our project. As we know that there is a rapid increase in the demand for both ceramic tiles and concrete, which is hazard to the environment as it leads to resource exploitation and pollution. There is a potential solution, that is partial replacement of concrete components like coarse aggregate, fine aggregate and cement with waste materials like scrap ceramic tiles, marble and granite. This will be both economical, sustainable and will reduce dependence on the natural resources. The objective of our project to investigate the effect on concrete qualities such as compressive strength, flexure strength, durability and workability with partial substitution of typical concrete materials with waste ceramic tiles, to determine the appropriate amount of discarded ceramic tile replacement that maximizes both cost saving and environment effects, to promote the use of waste materials for greener, more environment friendly practices and raise awareness with people sustainable, affordable alternative available in the construction industry. These are the list of materials which were used in this project. First, cement. Here we use OPC of grade 43 and various tests were conducted and results obtained are listed in the table. First, specific gravity and its observed value is 3.11, standard consistency 32, fineness was 178 and initial and final setting time was 90 and 265 minutes respectively. The compressive strength after 3 days, 7 days and 28 days were 25.5, 36.9, 47.6 megapascal. Fine aggregate. Here we use sand which is found near the river bank. The properties and its values are listed in the table. Specific gravity is 2.65, bulk density is 1.77 and water absorption for fine aggregate is 1.31%. And coarse aggregate used here were of two different sizes 10 mm and 20 mm and its properties and respective values are listed in table as specific gravity 2.85 and 2.82. Water absorption at 0.25%, 0.45%. Fineness modulus 7.125, 6.059 and bulk density 1.75 and 1.57. Material use was scrap ceramic tiles and these were obtained from the demolition of the residences and was used as a partial replacement ranging from 0%, 10%, 20%, 30%, 40% and 50%. And the properties of includes specific gravity 2.28, fineness modulus 6.78, water absorption as 4.5%, crushing strength as 14.58 and impact strength 22.3%. Let's discuss the methodology. The project includes 6 sampling S0, S1, S2, S3, S4 and S5 including 0%, 10%, 20%, 30%, 40% and 50% ceramic waste. And various proportion of material used are presented in the table include cement content, water cement ratio, water content, fine aggregate, coarse aggregate. Here coarse aggregate of 10 mm and 20 mm were used and ceramic aggregates. Results were obtained and the basic characteristic and properties are shown in the graph. The first one is slump value. The graph depicts that with increase in the scrap ceramic tile percentage in concrete reduces the slump value. Compressive strength. The test result performed on the concrete sample shows that concrete compressive strength slightly decreases in sample number S1 and further increases attaining peak value for the sample S3, that is 24.13, 34.74 kilonewton after 7 and 28 days respectively, and later on it gradually decreases with additional replacement when compared with regular concrete sample. Similar results were obtained in the split tensile test. The tensile strength of concrete first decreases and then gradually increases, attaining peak value at 30% replacement, then gradually decreases with additional replacement of natural coarse aggregate by scrap ceramic tile aggregate. Flexure test. In flexure test, a beam of size 50 cross 10 cross 10 cm was prepared with and without ceramic tiles and was tested for 7 days and 28 days, and similar result was obtained as of split tensile test. We see two graphs including values of compressive strength, tensile strength, flexure strength of different sample after 7 days and 28 days respectively. We can clearly see that first of all, the strength values of concrete sample decreases, and further for sample number 3 attaining peak value and then decreases. The same values are also obtained for the sample after 28 days test. Discuss about the conclusion of our research work. Based on the above test results, we can conclude that 30% of the natural coarse aggregate can be replaced with ceramic coarse aggregates, which can be utilized creatively for a variety of reasons. Although using more ceramic coarse aggregate reduces the value of concrete desirable qualities, we can clearly see that specific gravity of natural coarse aggregate and scrap ceramic tile aggregate was 2.85 and 2.22 respectively, and the workability first increases with increase in scrap ceramic tile replacement and further decreases. The similar results were also obtained for compressive strength, split tensile test and flexure test. Initially, after the addition of the scrap ceramic tile of 10%, the strength value decreases for the sample number S1, and later on it increases and attaining a peak value for the sample number S3 with 30% replacement of natural coarse aggregate, and strength values obtained were 24.13, 34.74 kilonewton for compressive strength. Hence we can say that 30% of natural coarse aggregate can be replaced with ceramic coarse aggregates. These are the list of references which we have used in our study. Thank you.